This conference will now be recorded.
Today we have 7 participants. What about the others? They are not joining today? Let's message them. So do you have any questions from the yesterday session? What we did yesterday? Did you try to practice? Run it yourself after the class? So do you have any questions from that? Otherwise, we can start further. Because today's session is going to be a little tough, little complex, I would say. So you just have to have that, because it's a learning curve that you are going through. So yeah, it's going to be tough. I'm being honest for that. Okay, so let's start. So up till this point we've covered while loops, for loops. So what we are going to do today, we are going to design a gradient descent algorithm. That is what we are going to do. This is the code that I have written. So I'll break it down for you, and we have some visualization also. We'll look at them and try to look at what exactly happening. Okay, so I will ask you to follow along. Just hang on. Good morning, Ashima. Okay, now I've cleared the output, so I think yeah, I need to run it. Yeah, I need to import the NumPy. No. This was my notebook which I was working on. No? Yeah. Here you go. Okay. Hang on a second, guys. So this was the function that I defined. Then I got these data points using the linspace. and this is my cost function. This is how it looks. Then this is my slope, and this is the slope of the cost function. And then we have this chart which tells me about the slope, cost function, and the slope side by side. Then we've discussed loop, how does loop works. Good morning. Then the while loop. Yeah, so while loop, for loop, they've been covered. So yes, we will try to look at this code basically. What is happening here in this particular line of code. So I will break it down for you step by step so that you can understand why we are doing what we are doing. And let me warn you, it is going to be getting complex when we move on, because this function that we have, it's basically x square plus 2x, x square plus x plus 1. Then we will have another function, another gradient descent, because this function was very easy because it has one single minima. But when we go back to other functions, I mean, they are not so easy. I mean, this function, if you say, it's a more complex function, which is x square minus 4x square, x raised to power 4 minus 4x square plus 5. So we will get the data points, we'll define the function and take the take the derivative, and then we'll plot it. So you will notice the difference, that yes, there is a difference. And the thing that we are covering, it's very easy, you will feel that. Okay, so what I'm going to do, I'm just going to say this is my gradient descent algorithm, and you also do the same code along with me. So first of all, I need to do the initialization. These three things I need to initialize. So what are these three things? Okay, let me talk about them. So the new x is going to be the first step, the position where I am at the cost function. Maybe this is my position 3. Where's 3? 3 is somewhere here, I guess. Yeah, this is my position maybe. And then I will be using a temporary variable wherein I'll be updating my position. While loop, repeat one more time. Okay, great. So basically, while loop work on the this thing. We have an argument, or you say condition. So till the time this condition is true, till that particular time, this loop will run. So I have initialized the counter as 0. And then I'm saying up till the run the loop, run the while loop while counter is less than 5. So till the time when the counter is less than 5, do this, print counting the counter. So it will go and print the counter. So initially it will be 0, it will check and it will run this particular statement. And then it will come at this point and it will increase the value of 0 by 1. It will increase the counter by 1. It will go again here. It will check the value of the counter, which is less than 5. It will print that. And so on, this loop continues up till the point this argument gets failed. So when we compare 5 is less than 5, then we get the output as false. So you can also try 5 less than 5. So we get our output false. So when this while loop sees this false, then it stops running, and then it print this thing, that ready or not, here I come, or the while loop completed. You can write whatever you want. So is it clear, Sunidhi? And we will be using for loop in it, for loop and if statement basically, and the break statement also. That's what we will be doing. Okay. So yeah, what I'm doing here, I am assigning 3 values first of all. So what are the 3 values doing? This is the value, this is my current position. So I will be updating my position now. So I am going to assign this new position to it and then going to update it. So what do I mean by that? Let me explain to you on this graph. So let's say this is my new x. So now if I'm at this point, I will check the derivative and I will move is in this direction. Now the x position has been changed now. So this position I will assign to x basically, and this will be previous x basically. This will be the previous x and this will be the new x basically. I have 2 variable here. If you can see, previous x and new x. So this will become my previous x and this will be the new x, which will be the new position. And then I am using something which is a step multiplier. So it is telling me the step that I'm taking. I'm moving 0.1 on this slope basically. Step multiplier, how many steps I'm taking? 0.1. Or sometime you read it as a learning rate, and this is also a part of convergence theorem. Or somebody says it's alpha, somebody says it's learning rate. Learning rate is we are learning, trying to learn a cost function, so we say it's a learning rate. Just give me 1 second. Okay, so yeah, multiplier is done. Now what we are going to do, we are just simply going to run a loop basically. This loop we will run. This for loop will run. So what is happening in this loop? I'm just providing the number of steps that I should be covering this distance. I want to reach to this particular point, and I'm telling my for loop that I want to cover this distance in 10 steps basically. I want to take 10 steps and I want to cover this distance. I want to reach to the minima. This is what my assumption is, that I will reach to the minima in 10 steps. This is what the range 10 is for, and I am assigning the as I said, I will be assigning the new x to the previous x, and the new x will get updated. So how it is going to get updated? It is going to update it based on the gradient. So what is the gradient? We have defined this function. If you can recall this derivative function, I'm going to pass the value of the previous x basically, which is 3, and it is going to check the derivative, and then it is going to give the gradient basically, and based on that I will have a new x which will be equal to previous x multiply step multiplier then the gradient. And this is the basically, you can think of it as it's a formula that we use to get a new position. So is it clear to everyone? Can we move on if it is clear? Is it clear to everyone or not? Okay, great. Now once this gets completed, this for loop gets executed, then what I'm trying to print, I'm asking it to print the local minima occurs at, because the local minima will be at the new position. It will, the new x will keep updating. It will at this point, then this will go and on. I want to know at this, what is the point that the new x is on. This new x will tell me that. Then I have the df. I want to know that the slope of the derivative at this point. What is the slope? What is the value of the slope at the minimum, where the minimum occurs? I also want to know the function value, because that is what we are trying to minimize, na? So I'll also check that. So let's try to run it and let's see what happens. So yeah, so I'm getting the local minima occurs at, this is the value for the x basically, which is at minus 0.124. 0.124. So it's somewhere at this particular point. This is my x now, so it's somewhere at this particular point. And then what I am saying here is that what is the slope? I'm trying to find the slope basically. The slope and the f of x is 89 and the slope is 0.75. So the cost function is close to this point, somewhere here or somewhere here maybe. And also the df is somewhere at this point, maybe at this point or this point. So do you guys follow? If you don't follow it right now, that's completely fine. We will visualize it and we will look at the graph basically. Then might be at that point you get the clarity. So this is giving me the value for the local minima and the the slope and the function value. So what happens if I go and increase this? Let's make it 100. Let's see. So can you see it changed the value? Now it is giving me 1.42, sorry, 1.42 5 and on, then e raised to the power 9. But no, it's coming out to be this now. So it's giving me value as in like this particular value. I need to convert this value. So that means e raised to power 0.9, you can think of it, it's close to 0 basically. It's close to 0, but the precision is not there. Can you see this precision 42592515, and the precision is not there. Can you see? In this one also, the precision is not there. 49 point, and the local minima now occurs at 0.49. Okay, if I go and increase this value, maybe just hang on, keep it at 500, then what happens? Now the slope is like 2.002. So that is not a good number for me. Then what do I need to do for it? Then I need to introduce a new variable which will be the precision. The kind of precision I need in my values, I will introduce that by using the if else statement. So I will have this new variable which will be called as precision. So I want a precision of 0.00001. This is the precision that I am looking for. So how I'm going to inculcate this precision into my model basically. So I will simply say this thing. Okay, forget this precision now, forget this one. We'll talk about this next. First of all, we want to check, how many steps we took. So let's do this. Let's print the step size. We want to find the step size basically. So step size we will be able to find with the help of this one. We will have under this for loop. So what I am trying to do, it might give me the negative values as well. I'm trying to store the step size. Step size is basically how much distance it is covering. As you can see, it is just subtracting the new value from the previous value. That means it is giving me the difference. Do you follow this? If this is my slope, this is my old value, this is my new value, then this is only going to be my step size, no? So I want to know my step size. So I am trying to find that out. And ABS is for absolute value. I don't need any negative value. That is why I'm using it. So do you guys follow this? Okay, so let's go and print the step size. So you will see as I run the loop, you will see the step size is decreasing as we go down the lane. The step size is decreasing basically, and I think I've talked about this yesterday also, because the slope is decreasing. If I come back to the slide, and if I can show you that again, yeah, because the slope, it's less steep as I move downward now. So obviously the step size has to be smaller, but I am showing you with proof that you can check that it is decreasing. I'm not just verbally saying it. You can see it was first of all it was 0.70, then it became 5.6, then it's 44, then 35. You can see, and when we are getting closer, you will see the step size. I mean, the step size is very small when we are getting closer. It's approximately zero. I mean, it's taking a very small step. It's not moving. It stopped, you know, at these point basically. It stopped because now it has reached to the global minima. Sorry, not global minima, to the minimum value. Let's not go to the global minima right now. So let's now what I want to do, I want to check how many steps it took my algorithm to reach to the minimum value. So what will I do for that? I will create a list and I will append all these values in that list. So did I talk about the append? How does the append work? End of line error you are getting. End of line. You have done some spelling mistake. Maybe you have missed on putting in some commas, maybe apostrophes. That's when you're getting that error. Check that out. It will point, the Python will point it out. Okay, let's say if I do this mistake here, you can see I don't have an apostrophe here. If I run it, I will get the end of line error. Can you see the same? Guys, can you hear me? Can you hear me now? Okay, so
Yes, audible.
sorry. Yeah, electricity issue. Now it's working. Just give me a second. Let me Can you hear me now? Is it better? Am I audible? Please type yes or no. Okay. So yeah, Sunidhi, did you solve that error or do you still have that error? So Sunidhi, can you see at my screen? I am also having that error. It's telling me EOL while scanning the string literal. This is the same error you might be getting. So that means you have not ended a line basically. So it is pointing me towards this, that there is a problem with this line. Local minima occurs at. This line is not enclosed basically. So when I enclose it, it will work. So you do the same thing. It should work then. So see, it's working on mine. So try to do the same thing. Okay. Yeah, great. So now what I will be doing, I will be creating list and two list basically, and I will be, so yeah, I was talking about the append function. Yeah, so what does the append function do? So let's say, did I talk about the append function, that do we have a append function in a list? I have, right? Or haven't? No, okay. So let's say this is my list basically, and if I go print it, this is how it looks. And now I want to add a value to this list basically. Well, how can I do that? I will be using the append function. This will append the value at the end of the list basically. If I pass maybe 2, then it will go. Now if you check the list, it has added 2 at the last. So I will be using this function here, the same append function, to add values to my list. So I am creating two lists basically. Just hang on, let me add some space. Yeah. So what I'm doing here, I am creating two lists basically. So yeah, let me have it here and then show it to you. So I have two lists basically, and in one list I'm storing the value for the x new values, and in the other list I'm storing the value for the slope value basically. I'm trying to store the slope and as well as the new list basically, list value. So what do I have to do? I have to use this basically. Now after running this loop, I'll be getting a value for the new x and the slope as well. So I will be appending these value to my list. Don't worry, I'll explain it to you again if you don't understand in the first place. So what is happening here? So now after once this loop runs, I have a value for new x basically, new x value. It gets printed every time this loop runs. So I am trying to append this value into my list basically. This is my empty list. It will have the first initialized value that I have given, that is 3, and then the rest of the value will get appended all the time. Now next is basically for the df. So I'm storing the derivative also, taking the derivative of the new value that I get and storing it in a list basically. So if I go run it, so this is how it looks. And if I go and check my list, so you can see it has all the values of new x basically. And if I also go to check the slope list, so it will have the value for the slope. Are you guys following what is happening here? Do you guys follow this? Am I getting too fast? Very fast I'm going. Okay. Okay. So, okay, let me give an example, then you might understand this thing. So let's create a string, okay? Let's create a string and call it hello. So what should I do if I want to append these values in a list? Append means I want to insert these values in a list basically. What should I do? So for that, what I will do, I will create an empty list. Empty list can be created in this way. Then what I will do, I will run a for loop on this string basically. For I in st. Okay, then what I'm going to do, I'm going to say ls dot append, and then I'm going to append the value of I in my list, and then I'm going to go and print the ls. So can you see this? So do you understand what happened here? I have a string and I said apply a for loop on that. It goes to this position, checks the and it gets this value basically, and then what it does, it appends that value into this list, and then again it goes here, check the value, and so on and so forth. So it comes at the last of the list basically, and I have inserted all the value. Then at the end I'm saying return the value or print the value basically. So is it clear, or still you didn't get it? You get it? The same thing is happening here. So there is some for loop going on, which is the operation that I have mentioned here. They are going to run for the 500 times. And there are different things which are happening. First, it will assign the value, which is the new value, to this one, which is the previous value, which is 0. This is a temporary variable again. And then what I'm doing, I'm calculating the gradient, which is my slope, by using the function that I have created. Where is that function? Yeah, the function that I have created, if you can recall it. So I'm using this function to calculate the gradient of each point of x, because only by calculating the gradient I am able to move forward. So once I have the gradient, to get the new position or the new x, I need to use this formula. This is the formula. Now after doing these, after following these steps, I have values for new x also, right? I get the value for new x. This is the last item, which is the new x value. So what I'm trying to do, I am trying to append that value in my list basically, so that I can have a list for the x values in which I have all the values of x, because I am going to use this particular list for the visualization to show you the graph basically. That's when you can understand what is exactly happening here. Now do you follow this? And then after this, what I'm doing, I'm inserting or appending the slope by using my function df on this on this value. So do you follow this? Do you follow this or not? If you guys will not respond, how will I know that whether you get it or not? Then you'll come and say that I did not understand it. You follow this, right? So is it very, I mean, like, difficult to reply? Yes, it is very difficult to reply. Okay, Sunidhi. Copy that. I'm just kidding. Okay, okay. I see. Now I have these two lists, and that's why I've shown you these lists. So these value got appended. Okay, okay. So now Sunidhi is following, and Neha is also understanding. Who is not able to understand, please respond, so I can also break it down for you. Who did not understand, please respond. So I am considering that everybody is understanding all the things. Great, great, amazing. Now the next thing that I want to do, I have this list basically. So I want to basically work on this step size basically, because when I've shown you the step size, basically how many steps were my algorithm were taking. So there are lots of steps, and it was not required basically, because and it was running because I have passed 500 steps. It could have done the work, could have done maybe in 100 steps only. I don't need to run for 500 times. So I'm not sure now that at what point is going to give me the best output. I'm not sure for that. So I'm going to use a different parameters to have a control on this thing basically, so that I can what I want to do, I want to automate this basically. I want to make sure that once my slope value or once my cost function get reduced to the minimum value, my step should stop. I should not run this loop anymore. It should stop automatically. So what do I have to do for that? I have to write the if else condition. I have to supply some condition that if this happens, then you should do this. If this happens, you should do this. So then I am going to use the if statement over here. So I can have a control on it, and also I can have a certain level of precision. So to attain this, what I'm going to do, I am going to use this statement basically. So I'll break it down for you. Don't worry what is happening here. I'll break it down for you. It is going to come under this. Yeah. So what I am doing here, if now I'm as I said, I am trying to attain certain level of precision. So I am saying if the step size is less than the precision, then break it. If the precision is greater than the step size, then break it basically. The precision that I have mentioned here, this much precision I need. So let's run it and let's look at the difference basically what happens. So this gave me something new also, which is called, so I am getting this output. Can you see loop ran this many times? Now it is telling me that my precision has been achieved only in 50 runs basically. It ran only 50 times, but initially I have supplied it to be 100. That means it automatically stopped at 50. Can you see this? 50. And now I have a level of precision also attained in the value of X also. In the value of local minima, it's at minus 0.49. Also, it's 7.009 and 750. So you can see it giving me a certain level of precision. So is it understood or not? Understood to everyone? So basically, I just automate this basically. That's what I did here. I did it automate. Because I'm not sure now when I'm running an algorithm, how many steps I should take. Why do? Because I am saying once this step is done, then break it. Get out of this loop. Don't go back and run more steps. Don't go back and run again 50 steps. I'm trying to save my resources. This is a very simple problem, but this usually doesn't happen when you are dealing with large amount of data. You have a huge amount of data and you don't want to waste your resources running the same loop again and again and getting the same answer. You don't want to do that. So you want to save on resources, you want to save on memory, and you want to save on time as well. So that's when the break statement comes into picture. So break statement, as the name suggests, it breaks the loop. So once this condition is met, it will not ask you to go get into the loop. So let's break it down again. So what happens now? It starts from 0 to 150. So first we have the value of n0. So 0 means it is going to run for the first time. Then once it's going to run for the first time, it will assign the value of new x to previous x. It will calculate the gradient. It will calculate the new value. It will calculate the step size also. It will append the value into this list. the slope value into the list, and then it will check. Now, if the step size is less than my precision that I have passed here, is it less? Then it say yes, it is less. Okay, then go back, do the same thing. So this continues, and once we have this, that step size, so that step size, it no is not less than, it's equal to, maybe it's equal to precision, then what I do, I just my loop comes at this point. Now this value is coming out to be true because this is the Boolean output. When I do some comparison, it gives me the Boolean output. What do I mean by Boolean output? Let's say if I'm comparing 5 is greater than 6, so it gives me false basically. So till the time my loop if is giving me false, this will keep on running. This will go back, run, this will go back, run. But once I have this true, so once this is true, or once it is equal, once it is 6, so it will also give me false. Once it is 7, it will come out to be true. So once this is true, then this statement will get executed, and it will say the loop ran this many times, and it will print the n value, because at that particular point n will have certain value, and then it comes to this point, which is break. So which is telling me get out of this loop, don't go back and run it, get out of this loop and print these statements. Now I am out of this loop, so I am at this point maybe. So then I will check if I have something to print, then I will print those values. So is it clear, guys? Is it clear to everyone? Great, great. So this is what my simplest gradient descent algorithm that we have coded on our own without using any library. We just use NumPy and we created our own function and we have coded this. So I will also ask you to run it and check if you are able to do that. Now what we are going to do, the next step that we are going to do, we are going to plot these values, because just by looking at and just by listening to my whatever I'm saying, you will not relate this very well until you see things in front of you. Until I show you something, you will not believe me, I know that. So I will what I will do, I will take the help of visualization, the graphs and the plots. I will plot, and then I will show you that whatever I am saying, if it is true or not. So df is not defined, that means Sunidhi, you haven't run the previous line of codes that you have. This df, have you run it? This is not, I think you did not run the cell, you need to run it. So Sunidhi, still are you facing the problem, or is it solved? Everybody, did you run the code? Can we move on to the next step? Try and plotting these values, and then we will have a better idea what is happening here. Guys, are you still running it? So everybody done with this code? You got the same output? How many times your code? So if somebody don't trust me, I mean, what you should do, you should just go back and increase the value, make it 500 or make it 5,000 and try to run it, and then see if it gets stopped at 50 or not. So now let's move to the visualization. Now this is the code that we have for the visualization, and I believe you will understand it. It's not that difficult to understand. I'm sure you will understand this particular code that I have here. So should I run it first, or should I break it down then run it one by one? Should I run the whole code then explain it to you, or should I break it down and then explain it to you? How do you want me to go about this? Please tell me, everyone. You want me to break down this code one by one, then run it, or just run it once, then explain each line what is happening? Run it first, then break it down. Okay, run the code. Okay, cool. So all of you are saying run the code and then we'll break it down. Okay, that sound good. So yeah, this is the running, and it's a huge code basically. Yeah, so I have plotted 3 graphs basically. This is my cost function. This is my slope of the cost function, and this is the close-up of the gradient descent. This is the close-up I have here. So what is happening here? So initially my value was at this point, and then I asked it to move forward by doing this step, basically by asking it to take a gradient descent, then change its value. Now this value has moved at this point. So you can see how big the step was. From this point, it gets to this particular point. Because the slope was huge at this particular point, you can see how big slope was. And once it starts moving, and once it reached at this level, that's why I have a close-up, so that you can see how many steps it took from reaching from this point till this point, which is the minimum value. And you can see it's the minimum value for the cost function. It's close to this point, basically. It's a minimum value. And for the slope has become 0. So that means we cannot move forward than this. We cannot move because slope is 0 now. This value of slope is 0. So we cannot minimize the cost function after this. And this graph is showing that how many steps it took to reach this point. So is it clear? Is the visualization clear? Then I can go back and explain it to you, all the lines, what is happening, what not. Everybody, is it clear to everyone? Great, you guys are genius. Great. So first of all, I'm passing this figure size, and I've explained you yesterday as well. Yes. I am doing that. I'm doing that, Ajay. I know it's a very huge chunk of code. I'll explain it to you. So I'm superimposing the gradient descent calculation on the plot. The plot that I had, I'm superimposing the values that I get from this point into my plot, the previous plot that I had. That how the gradient descent is going to work in the backend. You will not see this when you apply any algorithm. You will be not able to see this until you create your own. So this is just to give you the intuition so that you can think of how basically the algorithm works. So what I'm doing here, I am passing the figure size, which is 20,5. So which was the size for this 20. This is 20. This is 5. It's in inches. 20 inches cross 5. Then this is the chart. For the first chart is for the cost function. So this is 1, 3, 1. So this is 1 row, 3 column, and this is the first chart. I have 1 row, 3 column. The first chart is of cost function. That's why I have this. Then you know about this. This is a limit I'm putting on the x value. I need the value of cost function from -3 to 3, and ylim from 0 to 8. Then I'm giving it a title, cost function, font size, x label, y label. Then I'm plotting the value. Plotting the value of x and the cost function, giving it a color blue, and the line width and the alpha value, which is to make it transparent. Now I am the values that I have of x, basically the x values that I have. If I try to pass those values in a list, it will give me an error. Let me show you that. If I directly go past the x list, I have the values of x here in the form of x list, right? So if I go and try to pass the value of x into my code, it will give me an error. Let me show you that. So you can see unsupported operanda. This will not work. And as I said, while we are doing any scientific calculation, so we prefer to use an array, NumPy array. So I am converting the list that I have into a NumPy array. So now you will say that please show us how can we convert a NumPy array, sorry, a list to NumPy array. So definitely I will show it to you. So let's create a list which is 1, 2, 3, or 1, 2, 2, 4, 5, 6, 7 maybe. So I have this list. So if I go and check the type, this is a list. Now if I want to convert this list into an array, how can I do that? So I will just say arr is equal to numpy dot array, and I will pass in the list. Now if I go and print this array, so yeah, it has been changed to the numpy array. If I go check the type, so yeah, it's a numpy array. So do you guys follow this? What is happening here? So the same thing I am doing at this particular point, because I cannot pass the list for the, because I am applying a function, na? I cannot apply the function to a list basically, because the function is designed for a single value, but I can do that with the help of value by using a numpy array. So I will pass the values. This I will simply do set, yeah. Now if I go run it, it is working up and fine. So this is to give the color, this is to give okay, what exactly it's doing. Let's make it 10. Let's try to notice the difference, what exactly happens. So did you notice the difference, what happens when I decrease the value of s? Did you notice what happens in the graph? Yeah, so the size of the dots or the values of x will decrease. So s is for size, so that's why I kept it 100. You can tweak around with it and you can try different sizes, which gives you the best size, and then you can use it, that size. Yeah, so it looks better, right? So up till this point, I guess this is clear to everyone up till this point. If you have doubts in it, in the first chart that we have, please ask. If you have any doubts, please ask. Guys, please respond. I can at least expect a response from your side. I will share the whole code with you. I mean, this is the whole code. You can try it. So guys, is this clear up till this point? Can we move on to the second chart? No response. Okay, tell me please one thing I want to know. Can I ask you one question if that's okay with everyone? Can I ask you one question if that is okay with everyone? Is it very difficult to answer, to just respond back when somebody is explaining you things? Just assume that you are explaining me things, and so what you will expect from me? You will expect that I respond, that whether I am getting what you are telling me or not, because according to that, if I'm not getting it, you will, according to that, you will mold your points, you will give me different examples so that I can understand. So if you will not tell me that whether you are getting it or not, whether you are confused, how would I know, right? I don't have any superpowers that I can read your mind and what is going on in your mind. Yes, alpha is used for the transparency. Absolutely. You can change the value for alpha and check what happens. Try to tweak around the values of alpha. Now the second graph that I have is for the derivative. So same thing is happening in this particular graph. Same thing. I'm using a subplot 1, 3, 2. This is a single row, 3 column. This is the second graph. Then giving it a title, the font size, giving it a X label, what should be on the x-axis, giving it a font size, what should be on the y-axis, giving it a font size. Then I'm using grid. If you remember, grid is for these lines that I have here. I'm using grid over here. Then I'm limiting the value on the x-axis. I need the value on the x-axis from -2 to -3. You can play around with these values. You can change the values and you can notice the difference. And then I have on the y-axis -3 to 6 basically. Then what I'm doing, I'm plotting it. I am plotting with x1 values and plotting it on a function which is df. Df values I'm plotting it on, and then I'm giving it a color of sky blue, so it should be light color. And line width I'm giving, alpha value I'm giving. Then I'm using scatter plot again. So in this scatter plot, I'm passing two lists, the x list that we have and the slope list, which is over here. That is why I've stored the value of x list and slope list, so that you can see, you can visualize it, because you are not able to see these values now, so you won't be able to understand this. That is why I have stored it in a list and I plotted them. So slope list, then give it a color as red. Alpha, this is S for the size of the dots. Alpha is for the transparency. I want to decrease the transparency. And then I have a close-up chart. I want to look from this point till this particular point, how the points are scattered. That's why I have a close-up, so that I can explain to you that once it gets closer to the minimum value, there is a very minute change. The change is very, very small. That's what I can explain you. I'm using grid over here, giving it a title, X label. Then you can also give it Y label, but again, it's going to be the same, the Y label. Scatter, it's going to scatter the points now. You can see they are different type of plots. It's going to give you the points like in this way. If you use scatter plot, if you have x-axis and y-axis, so your point will be like this. It will not join the points basically.
Okay.
This is how the scatter plot looks like. It will just scatter all the points, in the region basically.
And what is plot then?
Then plot, yeah, I'm coming to that. So plot is basically whatever the function, basically it will give you straight lines, maybe it could give you any functions of that sort. So it depends on your function, how your points are lined up. It will change, give you the change, how x is changing with respect to y, or how y is changing. Let's say if x value is at this point, the y value is coming out to be this point. Okay, let me remove it, let me show it to you again. So if I have x value at this point, so y value may be at this point. So I have this point. Then if the x value at this point, I have maybe y values at this point. So I could have this particular point. Then I could have y values at this point and x values at this point. So in that sense, so plot is basically it joins all the points, So how the points are scattered on my graph, it will join all those points.
So connecting the scatter is called plot.
Yeah, you can think of it that way. I mean.
Okay.
So do anybody have any questions? Yeah. So what I'm doing here, I'm limiting the value from -55 to 0.2 over here, so I can see the minute changes. I can show it to you. Then I'm limiting the value on the y-axis as well. You can see the value we have from -0.2 to 0.8. Over here it was different. It was -3 to 6, and over on the x-axis -55 to going up till -20, 0.20. Right, then I plot this and I again use the scatter plot, and here it go. So if you want to understand the difference, then Ajay, what you should do, you should plot the scatter plot of the x values that we have in the function. Then you might be able to relate it. So I have these points, x point, and I have a function. So what you should do, you should plot it. So let me try to do that. Then might be you will understand this thing. So yeah, use this. Okay, so what I'm going to do, I am going to pass in two values basically, x values basically, which is x1, and I want to plot it those values with respect to my function. Let's see if it works, or do I have to convert it to array? Yeah, it is in array only. Yeah, it will work. F of x, I'm passing x underscore 1, and let's plot them. Let's see, plt dot flow. Can you see this, Ajay? Can you see?
Yes, very good.
Yeah, so now I guess you will be able to understand, because just by words, I guess that's not enough. Example always helps. So you can see we are not joining these points. I'm just giving the change. If the x value is this point, then what is the value for y? Okay. So I guess this is clear to everyone how x scatter and plot are different.
And again, I have one more question. What is linspace and what is array?
So it is a data
both are,
linspace is gives you the value spaced in a linearly. The linspace. If I go to the description of linspace, so it tells me that it returns the value, returns evenly spaced numbers over a specified interval. So this is the interval that I'm specifying, that I need my values in between 0.3.0, or no, I need the value from this point up till maybe 3. And how many numbers I need, I tell it that I need maybe this many numbers. I need 100 numbers. Yeah, so this will give me the numbers linearly spaced. If I go and check x1, so this is how I get the numbers. So the type, if I go check the type, so it is going to be an array. So it is again a data type, a NumPy data type. So we use array for doing scientific calculation. It's more robust, yeah, than a list. So how many points I had? Okay, I had 500 points. Yeah. Okay, let's change it. So let's try to change some values, and let's try to see what is the difference we get. So this is the plot I get when I have more points. You can see now. Now maybe I need to increase the distance. Maybe I need the point maybe from 5 up till 5. If I go run it, maybe I need more points in between then. The graph is small. Give it 20. So you can see I need maybe less points. Yeah. It's not updating, I guess. Yeah. And this is how function looks like. Derivative, the slope. Let's see how it changes. I have no, this range should be minimum. I mean, then everything will get messed up. Better. Okay, now what if I change my starting point? What happens? Now I am saying that my initial point is this in the positive direction. What if I change it from this? I'll say it's -3. Let's see what happens. Let's try to tweak that. So now I'm going to say that my starting point is -3. So see, it has completed the iteration only in 49 steps. Let's change the graph and let's see how the graph changes. Okay. X and Y must be of same size. So there is something wrong that happened. Okay, X and Y. PLT dot scatter values. It's giving me error at this point. Okay, it has different values. New. Let me check the length of this. Oh, it's storing only 51 values. Okay. What is the length of this? Oh yeah, one value is higher. Okay. So why is that? So see, only one value difference can, mess up with your code. One value difference, even that can mess up. So this is okay. Okay, I have to run it. Okay, I have 500 points. Okay. Value is not defined. Value is not defined. Okay, I think I messed up here. Okay, I haven't run it. My bad. Yeah. So can you notice the difference? Guys, can you notice the difference? Now it has shifted to a different direction. The cost function, still it is reaching to the minimum level. So yeah, because we don't know, from where we can start randomly. We might start at this point, we might start at this point, we might start at this point, but our aim is to reach to the minimum value. So you can also tweak around with this and check if it is working well or not. Maybe you can start from -2 and let's see if it works out. Now you can see it's completing in 47 steps only. Let's see what happens then. So yeah, you can see now the steps are decreases, you can see. So change the value and see, the difference. So I'm just gonna keep it 3. You can go and try out different values and check how this works basically. Yeah. So do anybody have any questions?
Yeah. So how to decide which side will be the fine to
So
get global maximum? Mhm.
so basically we cannot decide that. That is the problem. We'll talk about this. That is going to be a random guess. As I said, this is a random value that I'm giving. I'm not sure. This is going to be a random
I
guess.
think I think size does not depend on anything. Actually, we are getting global maxima. That's it. The point is to get global maxima.
Okay, what if now this was a very simple problem. What if I have such sort of graph? What you will do then?
Yeah.
I'll talk about this.
Then we have to look for the minimum number of repetition.
I will talk about this in detail. How this works basically. Maybe what happens, like you might have started from here and you might end up here. And this is not the maybe this is not the minima. This is the local minimum, but
Right.
this is not a global minima. Right?
Right.
This
Right.
is right. Or maybe you started from here and you ended up somewhere here. So that is why we try out, then we have, stochastic gradient descent for it. We try different random numbers and try to get the values and then compare them. That's again a different thing. So it depends on the complexity of your cost function. You might have multiple minima. One could be the global minima. You might have 2, 3 local minimas. So we will talk about this. This case is going to be multiple minima, and we'll start with initial guesses and advanced function we'll try to develop, which will take multiple arguments. Okay, guys. So let's do one thing. Let's take a break for 15 minutes, and then everybody can come back, and we'll look into this second problem that we have multiple minimas and initial guesses, and try to understand what is happening here, why we have this sort of curve, and all that. Okay, guys. So let's take a break. Yes, yes, yes. Okay, guys. Thank you so much, guys. Okay, guys, can you hear me? Guys, can you hear me? Can we start? So everybody's back. Can we start? Okay. So far, what we have covered, I guess this is clear to everyone. So the cost function was the first case that we were discussing was, let's see what was the cost function. Let me delete this extra line code from here. Yeah, delete this. I also don't need it. So yeah, my cost function was f of x square plus x plus 1. And this is a parabolic function basically. Now I want to use a more complex function basically. And then I want to check the function. First of all, how does the function looks like, the slope of the function, and taking the derivative of the function. So this is going to be the function that I will be using. So let's write it down. So I will go and select the markdown. So I'm just going to copy and paste it. You can write it down if you want. So what is happening here? I'm just giving one hashtag, then giving an example to multiple minima versus initial guesses and advanced function. I'm using latex tag again, giving it a name. F of g of x is equal to x raised to power 4 minus 4x raised to power 2 plus 5. If I go run it, this is what I get basically. So now, first of all, I need my data points, right? So I will run this cell to get my data points. Now, if I go and check my data points, so do I have this data points or not? So I do have this data point. This time what I did, I asked for numbers in between -2 till 2, and I have asked for 1000 points basically. Yeah. So here is a challenge for you all. The challenge is basically I want you to write g of x function. This is my equation. So I want you to define a function which will be g of x and dg of x, which is the derivative of x, the one we did at the top. Same way, I want to define the function first of all, and then take the derivative of that function like we did here. So if this is my function, how you are going to take the derivative? Yeah, this is my function. So please go ahead, and it's not going to work. Yeah, I'm not able to share it. Okay, can you do that? Okay, great. Please do it. Somebody is able to do that, or should I do it? First of all, I need the function, Ajay. Then you can give me the derivative. Okay, g of x and then dg of x. So this could be my g of x basically. Yes, everybody is, I guess, able to do that. Great guys. It's wrong. This is the function, not the derivative. This is the function. Neha, this is a function, not a derivative. Yeah. So what is the derivative? So Ajay, the derivative, as Neha was saying, 5 is a constant. You cannot take 5 into account. Yeah, Compal is good. Great guys, great. So we have two functions basically, g of x, which is x raised to power 4, x raised to power 4 minus 4x, and x raised to power 2, then plus 5, then I have a derivative which is equals to 4 multiply x raised to power 3 minus 8x. So this is my function, this is my derivative. Now I want to draw the plot. Now this is again a challenge for you all. The way we did the plot for these two functions, I want you to draw the plot for it. Can you do it? Here is the code. Just have to change few values and that's it. Boom, you'll have the plot. If you can do it from your own, I mean, that's amazing. Give me the plot. This is what I should get. Yeah, but give it to me. You just have to change few values and then you'll have the plot. So I encourage everybody to do this. So everybody is doing it, I believe. Ajay, are you done?
Trying. Just 1 second.
Okay. So I haven't received any answer so far. Are you guys getting any errors?
Getting errors only.
That means you are trying.
Hmm.
That's good. So check the values, which values you are passing. Are they right? Are they wrong? What values are you passing? Break the code, don't go for the whole code. Break it. Okay, just plot. Don't use a subplot. Just disable the subplot. Disable the subplot and draw individual plots. Disable this one. Draw one plot at a time. Might make better. Done. Okay, share the code so that everybody can see it. Okay, he's done this plots as well. Okay, great. Lovely. No, Sayed, this is not I wanted. I want
got it.
I want to plot my You
I
got
got
it.
it.
Great.
Yeah, yeah.
Okay, amazing.
W.
Sayed, I
The
asked
plot.
you to plot plot was a problem.
The output is W.
Yeah, output is W. Yes, yes. You got the cost function, no?
Yes.
Great, great. Now look for the slope. Don't use the limit, just leave the limit. First of all, don't use the limit, X limit and Y limit. Just disable them, and
Mhm.
then you will see. Then according to that, looking at the graph, use the limits. Yeah, he got it. Great. So you can do this, guys. I mean, you can break down the code and then try to solve it. Subplot you are giving. Okay. Disable a subplot.
What is this, a scatter plot? I just trying and I got something different shape.
Don't try scatter now. Scatter,
Okay.
I told you, na. Scatter, I told you, is gonna give you only the points. Whatever the point you will have might be this sort of shape.
Hmm.
The points are not joined. How the values of X affecting the values of Y? That's what the scatter plot does. It does not joins the point. So yeah, guys, this you should get this sort of value.
Again, the sinusoidal wave. I mean, sine curve.
Second
Bit of
chart.
sine. Yeah, second chart. Slope of the cost function.
Yes, 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 yes. Okay. Then we have chart 2. Okay, now I can enable it. Let's try to run it. Okay, you are doing one top of the other. Okay. Okay, this is what I get. Okay, now use the X limit. Limit these values. Okay, let's me try Kompal's answer.
Figure
Okay,
size. Figure size.
yes, that is the problem. I mean, it's good to see you all trying. It's good to see. This is what I was looking for. Great, great, great. plt.xlim ylim, use that function. For y, how the values are affecting from -2. Yeah, it's also going from -2 to -2. Yeah. No. For this, the values are going from 1 to 5. 1 to 5, I guess. 0.5 to 1 maybe. And for the other graph, the x values are from -2 to 2. Okay. And it's going from -15 up till 5. No. Too strong. Okay. Cost function is messed up. Okay, much better. -2 to 2. Yeah, this is what I was using there. 2 -6 to 8. Okay. -2 to 2, 0.5 to 5.5. Yeah, it's 0.5, no? 5.5, yeah, up to this point. Okay, cool. And for this is -2 to 2, and then we have okay. Yeah, it looks much better. Color, yes, we can give it some color. Give it a sky blue color. Give it a blue color. Sky blue color. Yes. Line width. Yeah. So everybody have this graph or not? Everybody have this graph? No. Okay. Use this code, Sunidhi, if you don't have the graph. Use the code that I've shared. If all of you have this graph, then we'll talk about this, what is happening in this graph. Let me know once you draw this. Let me know, okay? So do everybody have this graph? You just have to copy and paste the same code. Great. Now let's look at this graph. What does this graph tells us? This graph tells me that this is my cost function. And it tells me that I have two minimas. Minimum values are existing at 2 points. At this point, can you see my screen? Just hang on, I guess. Guys, can you see my screen? Hello? Can you see the highlighter on my screen? The red one? Okay, cool. Yeah. Okay. So this point and this point are the two local minimas basically, or we don't know which is the minimum value. Just call them right now, just call them minimum values. Right now I have two minimum value, right? When I look at my slope, what do you find from your slope? Where is the slope minimum? If I go and maybe draw an arrow, so at this point, at this point, at this point, it is 0. Can you see this point, this point, this point? If I can draw a line, let me draw the line. Yes, can you see this is this at these point basically my slope, which is dgx, is 0. That means it is cutting the cost function at 3 points: this point, this point, and this point, out of which 2 of them are minimum. Okay, hang on. Out of them, 2 of them are minimum values, and 1 of them is the maximum value. Can you understand this looking at the graph? It's very clear from the graph. So everybody is able to understand what is I'm talking about, that why do I have minimum value and maximum value. This graph is the slope of the function is cutting at 3 points. This point, again, let me use that here. This point, and the last one right here somewhere. So what do I need to do? If I am at this point, I want my function to go in this direction and reach at this particular point. If I'm at this point, I want my function to come to this point. If I'm at this point, I want my function to come to this point. If I'm at this point, to come to my function at this point. This is what my goal is. I don't want, if I'm at this point, then my function should go this point, and obviously it will not go. But how can we achieve that if there are 2 points basically in the minimum value? So let's look at that. Let me raise it. Yeah. Now what we are going to do, we are going to create gradient descent again, and this is going to be a bit advanced, I would say, but for that you should be aware about the function, that we can create functions in Python. So let me give you a little introduction about functions, how a function works. Yes, so basically, let's say I have this list. I will give you simple examples so you can understand. I have this list basically 1 2 3 4 5 6 7. This is my list. So what I want to do, maybe I want to check multiple times that I want to extract the even values from this list maybe. and I want to do this multiple times in my code. So if I am doing something repeatedly or again and again, then I might want to automate that task. Or what I want to do, maybe I want to create a function with which if I pass the list, or if I have something that I can pass on, and I can get the even values out from that list. So this is what we are going to do. So we have to use a def keyword, which is a definition or defining the function. So I'm going to give it a name, maybe check underscore even, and this will take a number. If you will pass a number, it will return if it is odd or if it is even. So I have to use two things. I have to first of all do the iteration on this loop. That means I have to use the for loop. So I will say for I in ls, and then I have to use the if statement. So what I have to say, how we check if a number is even or odd. Let's say I have maybe 5. So I want to find out if this number is even or odd. How do I check that? You tell me, please. How you check if this number is even or not mathematically, not just by looking at the number. By using mathematics, how do you check? What do you do? Please tell me. Ajay, you will not speak, please. Sayyed. I was asking for others also. What about the others? What do you think? I'm not asking you to write me a code. I'm just asking for the logic. What should be? Yes. And okay, you divide by 2. So what should we get when we divide it by 2? Okay, let's divide this by 2. So what should I expect, Ashima? If I divide by 2, I am getting 2.5. Okay, so you are saying a remainder will be 0. Okay. So do I have anything in Python with which I can calculate the remainder, Ashima? Do you remember yesterday class we've discussed this thing? Yes, what is it that I can use to get? Absolutely right, Sunidhi. So I will be using this modulus, and this will return me the remainder. So it is giving me the remainder 1. So I can put up a condition that if the remainder is 0, that means that function or that number is a even number. So if that is not 0, then that is not an even number. So I will have this if statement. I am telling my program, if I divide I, take the modulus, and that is equal to, double equals to means a comparison operator. We are comparing it. If I get a value of 0, that means that is even. So what I will print, I will say print, oh sorry guys, print I is even. Then I can also have a else block which will print odd. I is odd. Let's see how it works. So that means if I use check underscore even and I pass in the number maybe 5, so there is a problem. I'm getting it's giving me all the numbers. It's checking the iteration for all the numbers. Then what do I need to do? I need to do something about it. I need only one output. Maybe I'll use a break statement over here also. One is odd, but that is also not right. So what should I do if I want to check this? So maybe I have to use a function which will be the range function. Let's try that out. Maybe I'll say for I in range this, and then giving me the error. List objects is not iterable, is not an integer. Oh, sorry. My bad. 0 is even. Okay, let's remove this. So it's telling me that 0 is even. So what should I do? I only want to extract as 5. Is Sayed, can you help me? Sayed, Sunidhi, Neha, Ajay, can you help me? What should I do in this case? What should I do? Please help me out. What should I do? Okay, problem. Okay, solved. I was expecting an input from you guys, but that's okay. So yeah, this is the way I can check it. Is it clear to everyone what I'm doing here? I'm taking the input from the user and then checking the value, if it is even or odd. So let's create a simple function now. So in this function that we have created, it was taking a single input from the user. Is that right? Single input. What we want to do, we want to create a function which will take multiple input, because this function that we have, gradient descent, it will be taking multiple input. So let me give you an idea about that. Let's create a simple function, a function for addition of numbers maybe. Let's do that. So I'll define, maybe call this as addition add. So let's say it can take 2 inputs, A and B. What it should return? It should return A plus B. If somebody calls this function now, passed in 2 input, which is 2, 5, they will get the output. But what if they want to add 3 numbers? Let's try to do that. So if they will try to do it, it will give them the error because we have only defined 2 inputs. So let's add one more over here. It's working fine. What if I want 4 inputs? Give me an error. I need to define it in the function. D. Okay. Addition is not performing. Yeah. Cool. Okay. So now I have these functions. So if I go and try to add 2 numbers, then I'm getting error. But now you would ask me that, sir, I have defined 4 inputs. That means I can pass less number of inputs as well. That is my choice. But no, you cannot do that. If you want to do such cases, then you might initialize the values of these two variables. So what you should do, initialize them. Let's c equal to 0 and d equals to 0. Now if I run it, it will work up and fine. So in this way, I can also pass in some initial value to my parameters or the attribute of my function. So is it clear to everyone, so that we can move into this section, try to understand it, break it down? Is it clear to everyone how functions are working? Everyone, I need responses from everyone. If anybody have any doubts, any questions, please ask. Now, if you have this question, sir, can I check for a list? I don't know how curious you are, but yeah, you can also check for the list as well. So let's try to see how can we check the element. I want to check all these elements because that's when I started the discussion for that. I will check all the elements for this particular list. So should I explain it, or I mean, is it okay? Should I explain this, or is it clear? I mean, is there a need for it? Okay, let's do this. For I in a range, because then I might be using some function again for the length of this, and I'm taking input as ls, and then what I'm doing is okay. No, problem. Yes. Okay. If I, okay, if n, yeah. Now if I pass in the list, which is ls, oh no, problem. Let's call it l. Yeah, so it will check all the elements of that list. 0 is even, 1 is odd, 2 is even, so on and so forth. So this can be applied to a list. You just have to use the for loop. Okay, now look at this function. So this function is just like this one, but we have just made few changes in it. At this point, we were not using a function. We were not creating a function. We were simply passing in the values. We have to pass the values every time when we want to use it, and we have to write down these loops. What if I create this function? So what is the advantage of creating this particular function, this gradient descent function? So let me talk about this a little bit. Just give me 1 second, okay? Okay, guys, can you hear me? Okay, so you might be thinking, so that you have created this, whatever you did some Python loops and all. We are able to get our answer. Why we are going to new thing, which is a function? Why we are creating this function? Okay, so you have so if you have used or done looping here, we have done some loops, if else statements, we have done that. If you want to use this again, then I might have to come here, copy this code, paste it at that position where I want to use it. What if I don't want to do this? So simply what I can do, I can create a function and give it a name like gradient descent. So every time whenever I want to use gradient descent, I have to pass in these arguments that I have here. So some of the arguments are predefined. Some of the arguments I might have to give the value, like the derivative function. I have to insert the value, what is my derivative function. Then I might have to tell about the initial guesses, what should be the initial guesses. Then I should be talking about the multiplier. I don't have to mention the multiplier basically because it's already defined. So the same thing is happening, whatever was happening here, same thing, nothing is new. We are doing the initial guess which will be passed by the user. What is the guess? Because now we are making it dynamic. It was before this, it was static. Now it is dynamic. All the values which was there, they were there, we cannot change them, but now you can just change the values just by passing in this argument of the function basically. So the first thing which is happening, assigning the new x to the initial guesses, then creating a list of the new guesses, then taking the slope, then running the for loop, then taking the step size, appending them in a list, and then returning these three things: new x, x list, slope list. Three things we are getting in return. At that point we were only getting two, but here we are getting three things in return. So if I go and run it and run this cell, so you can see I'm able to, the local minima is occurring at to be 1.41, and I'm able to do that in 23 steps. That means where so you can see my initial guess was 0.5. That means the x value was 0.5. So where is 0.5? It's somewhere here, na? Somewhere here. Yeah, it's somewhere at this particular point. So this function is going to come to this minima. What is this minima value? Where is it reaching? It's coming out to be 1.41. So let's see, is that true? Yeah, it's somewhere around that. That means it's reaching up till this point. So then again, what I'm doing here, I'm defining the values. As I said, you can pass the function by using the positional argument or by using the naming argument. So in this case, what I'm doing, I'm giving the naming argument because this was the name that I have defined of my derivative function here. So I'm giving the value. What is actual my derivative function is dg. Then initial guesses. Now I'm saying I'm on the negative direction. Up here on this side, right? I'm going downward to come to this point basically. That is my motive. So if I try and do it, then let's see what happens. Multiplier is the step size, and precision, you all are aware. Now I am able to reach that point in 56 step, and this is my minima. So yeah, the minimum you can see it's the same, just that it's on the negative direction, one is on the positive direction. Now also I don't have to pass these parameters, initial guesses, because I have already inserted them in my function basically. I've already defined their values basically in my function. So I can also do this with even numbers. Maybe if I want to add two numbers, I can also define the value for C1 and the value for D to be 1. So what is going to be the answer of it? It's going to coming out to be 9. No. Yeah. So now it has taken those value into account, which I have predefined. So this is what I get. So do you guys follow this up till this point? So now my initial guess was I am at minus 0.1. Where is minus 0.1? So minus 0.1, 0.1. It must be somewhere here now. Minus now, minus is, yeah, this is 0.5. So minus 0.1 must be somewhere here, right? Then it is able to reach to the minima at 34. So what you can do, you can tweak around these values and then you can get the output. So guys, do you have any questions till this point? Any questions you have? Please ask. If this is not clear to anyone, please ask questions. Okay, yeah, I will repeat again. Yes, please. Okay, so Helena, what do you want me to? The code is difficult. No, it's not difficult. I mean, if you break down the code, it's easy. It's not difficult. Because I have a limited time to explain you this code. That's why it might sound difficult to you. But if I explain it in a half an hour, then it will be easy. And if you go back and look at this code on your own, then you will find it easy. So Helena, from where I should start? From the beginning? And it's the same code, Sunidhi. If you understand this particular code, did you understand this code, Sunidhi, or not? So Sunidhi, it's the same. It is absolutely same with minute differences. It is returning me 3 values and I am using a function now so that I don't have to write this code again. Simply, I can call this function, pass in the parameters value, and I can get my answer. The same thing is happening from the gradient descent code. Okay, cool. So this one, Helena, you were talking about this one, the first code that we wrote, or the second one, which is using the function? Which one you want me to explain? The first one or the second one? Okay, second. Okay, cool. Okay, so Helena, tell me, did you understand this code? First of all, tell me, did you understand it? Helena, do you understand this code? Yes. What is happening in this code? I'm assigning a new value, then a previous value, a dump value, this is 0. Then I'm using a step multiplier, which is going to be my step size, or you call a learning rate. If you Google it up, somebody says a learning rate, somebody says alpha value. Then I'm using a precision to get some precision in my output and to terminate my loop once I achieve this sort of precision. Then I'm creating a list to store my new values, x new values, and then I'm creating another list which is for the slope, and I'm storing my slope in another list that I have. Then I'm using a for loop basically. So what this for loop is doing, this is giving me my new value after applying the gradient descent, and then I'm checking the step size, printing the step size also, that is also not important. Then I'm appending the value into it, and then I'm checking to terminate my loop if the step size is less than or equal to my precision. Terminate the loop and give me the number of time, how many times this loop ran. So the same thing I am doing here, except this, I am returning multiple values. So with the return function, there is a return function that we have with which we can return some values. So I'm returning 3 values: new x, x list, and slope list. So new x is the value of new, which is the latest value of new, x basically. And x list is the list that I have, which I will be using for the visualization when I do the plotting. Then slope list, which also is essential for me for the plotting purposes. So over here, I am passing these parameters so that when I call this function, I will not write this loop, I will just pass the parameter. As you can see, when I'm calling this function and I'm passing in these values, dg, which is dg, and then I'm passing in this value, which is my initial guesses. Then I'm passing it 0.2, which is my multiplier, then precision, which is this. And then maximum iteration I've already defined, so I'm not passing those maximum iteration, how many maximum iteration should be there. And I am assigning these three values into three variables, because I will get three output now. I will get three output. One will be x, new x, which will be my local minima. Then second will be the x list, which will be the list for x. Then there will be the slope list. So I am assigning it to a new list, which is a derivative list. And then I'm printing it out where the local minima occurs by printing this value, and then the number of steps by giving the length of the list, because this will store the values of x, how many times x ran. So I'm just using the length function to give me the length of the loop. Same thing is happening here with few changes only. Right now I am assigning it to equal to my function dg. You can also do the, I've talked about this naming argument. I'm giving the name of the argument and defining it to the value which I want to pass in. And initial guesses, which was here, I'm telling the initial guess is equal to this value, then multiplier and precision, then I'm printing it out. And same thing is here. I am not passing all these parameters which I've already defined. I'm not passing these values. I'm only passing two. Now next time when I need to call this function, I only need to pass two parameters, the derivative and the initial guess. Rest of the things will be done automatically. So do you understand this now? Please tell me. Do you understand it or not? Great, great, no problem. So I think that's it for today. Now we will be doing the plotting, and then I have some other function that we should be talking about, the learning rate, how it affects, gamma data visualization with 3D plots. So I just want to take the input from you that should I explain these things in depth, or should I just move to the algorithm part? This is more of a mathematical and a visualization concept. So should I stick to these concepts, or should I go towards the algorithm? Yes, I will definitely, I will share. So please tell me, what should we do? Syed, it will take some time. If you need to write this code on your own, it will take some time. So please answer this question to me. If in tomorrow class, what should we do? Should we discuss more on these fundamental concept, or should we just jump into the algorithm part and apply algorithm? Tell me. Should we discuss more fundamental? Yes, algorithm is important, but if you don't know the fundamental, you will stuck one day. But I am just, need description. Okay, description in detail. Okay, give me 1 second. Let me share the code with you. Sorry guys. I'm sharing the code right away.